We are going to learn how to safely measure current in a standard DC circuit. So you're going to want to plug your lead into your digital multimeter, but you're going to want to plug it into the ampere section because we're measuring current. You're going to turn the knob to the appropriate section. Notice how it says DC in the corner. That is because we have a DC voltage supply. So to safely measure this without blowing the fuse, it has to be in series. That is the key part. So we have a standard voltage divider with two 1 kilo ohm resistors in series. So the total resistance of the circuit is 2,000 ohms. We have a 5 volt DC voltage supply. So using Ohm's law, V equals IR, 5 divided by 2,000 is 2.5 milliamperes. So we should expect a similar but not exact answer. So first we're going to break the circuit, and we're going to plug this in series and keep our eyes on the digital multimeter. That is a similar answer to what we expected. Now it is not exact because this says 5 volts DC, but it is not exactly 5 volts DC. These are 1 kilo ohm resistors, but they are not exactly 1 kilo ohm resistors. So if we were to measure voltage and resistance and then use Ohm's law, we would get the same answer that appeared on our digital multimeter. Here we have a diagram of the circuit. Notice how the green circuit is not connected at the moment, so we're not going to worry about that right now. First we're going to take a look at the circuit drawn in black. It is a standard voltage divider, and both resistors are in series, so the total resistance of the circuit would be R1 plus R2. So the first thing to safely measure current in the circuit is you have to break it. And once it is broken, you can insert your leads so they are also in series with the circuit, and that will give you a reading on your digital multimeter. So now we're just going to close the circuit back up. And now we're going to add on a parallel bar. So we're going to close this circuit. Now for argument's sake, let's say the first current we measured is I1. I1 comes into the parallel bars and it will split into I2 and I3. I1 equals I2 plus I3. So as they split up, they'll go through resistors and join back here, and they'll equal current out. Current out equals current in. So this will equal I1. So to measure current at any point within these parallel lines, you would do it the exact same way. You'd first break the circuit, and you'd insert your leads in series so you don't blow your fuse. That is very, very important. And you would get a measurement for current. So that's all for current.